Hey everyone, welcome back. I'm your host, and today we're diving deep into Kubernetes, how it works, why it exists, and the complete workflow behind it. Let's get into it. Eventually, the container becomes overloaded. If it crashes, your application goes offline. That's exactly the problem Kubernetes was built to solve. Kubernetes takes that single overloaded container and gives it a system to live in, one that watches it, manages it, and keeps it alive. Instead of one fragile container, you now have many, all managed automatically without you touching a single server by hand. That's the core idea. Kubernetes is a container orchestration platform. And here's what that actually looks like. Every Kubernetes setup is called a cluster, and a cluster always has two halves. On one side sits the control plane, the brain of the cluster, making every decision. On the other side sit the worker nodes, the muscle in the T where your applications actually run. The control plane and the worker nodes talk constantly and subtly, and that conversation is what keeps everything running smoothly. Inside the control plane, the first stop is the API server, the front door every request has to pass through. Right behind it sits the scheduler, deciding exactly which worker node is best suited to run your application. Next is the controller manager, constantly watching the cluster and fixing anything that drifts from what you asked for. And underneath it all sits ATCD, the cluster's memory, storing the exact state of everything, all the time. API server, scheduler, controller manager, and ATCD. Together, that's the control plane. Now let's see where the work actually happens. Every worker node runs the same core pieces, layer by layer. First, the kubelet, the node's local agent, making sure containers are running exactly as instructed. Below it, the container runtime, the engine that actually starts and stops the containers themselves. Add kube-proxy for networking. And finally, pods, the actual running units your application lives inside. So what actually happens the moment a real user makes a request? Watch the path it takes. It hits the API server first, gets validated, then the scheduler decides which node should handle it. Tells the container runtime to start a pod. Does that make sense? Inside that pod, your container runs the actual application and the request finally gets its response. But you rarely manage a single pod directly. Instead, you define a deployment, which controls a replica set. The replica set's only job is simple: keep the exact number of pods you asked for always running. Now, with multiple pods running, how does traffic know which one to reach? That's the job of a service. If a pod ever crashes, the replica set notices instantly and replaces it. This is Kubernetes healing itself. The service spreads incoming traffic evenly across every pod. This is load balancing, handled automatically. And when you ship a new version, Kubernetes replaces pods one by one, never all at once, so your users never see downtime. Put it all together, and here's the full picture: from ingress to service to deployment, all the way down to the container running your application. Now you've seen how Kubernetes manages applications from deployment to scaling. In the next episode, we'll explore its in depth and most important unit in Kubernetes: